Hello everyone and welcome to What's New in C# 14. Today I'm showing you extension members, the new way for you to add properties, methods, and even operators to existing types. Now for a very long time you could use extension methods in C#, but this is different. This is a level up. So let's have a look. Okay, let's imagine that I'm building a game, a tiny RPG which I'm gonna call World of Itemcraft. In that game, you can have items. You can even combine those items. To begin with, I have something very simple, just instantiating my axe, and then I'm just printing stuff to the console. Let's have a look at my domain folder. So here I have only one item. It's an inventory item, which is the one I instantiated there on my program. It's read-only because I want it to be immutable. It's a record struct because it's a value object, not a reference, and also a record because I want to get those nice default implementations for equality, to string, and all that. And then I have three properties. So the name, the base damage, and the rarity. And that's it. Pretty simple, right? I just run this. Welcome to the world of Itemcraft. Inventory item acquired. Awesome. Now I want to add properties and methods to this class. How can I do that? Well, the first thing, it's the obvious thing. Change the source code. Why wouldn't I? Because sometimes you cannot do that. There are plenty of scenarios and reasons where that's not possible. For example, if you pull in a class or struct or whatever from a NuGet package or whatever external library anyway, a third-party library that you don't have access to the source code, but you still want to add to it and you still want clean code, so you need to find a way to do it. Another reason would be if this class was auto-generated. So for example, if you use gRPC or if you use ORMs like Entity Framework or whatever, you're gonna have those generated codes that you don't control and you cannot change because they keep getting regenerated with every build. Another more practical real-world reason will be if your teams share that model across different systems, across different things, right? So you may not actually own the change of that model in your isolated agile teams or whatever it is that you do. And even if you do, you don't want to change it because it will change for everybody. So that needs to be a controlled change. Another reason will be legacy code. You may have stuff that you need to work with, but you don't want to touch it because the whole point is that you're building something on top, right? And then moving the system forward. So you don't want to mess about with the legacy code and break all kinds of legacy stuff that you're not assigned to deal with. So again, you can find a different way of doing it in a safe way that still moves the code base forward and makes it all modern and nice to maintain and all that, while not touching the original thing. Okay, so what can we do about it? If you are an old-timer C# developer, you will know about extension methods. These have been around for a while. What is the traditional extension method? Well, so I have an extensions folder here, and then I created a file called InventoryItem extensions outside my domain to keep things clean. That's the whole point of it. The first thing that needs to happen is that that class needs to be static. So it's a static class. And then I declare whatever method I want to call on my existing type, static as well. And the first parameter has to be the name of my type with the this keyword in front of it. And boom, that's it. Then I just add whatever other parameters I want, whatever logic I want. The important thing is that now I can call damage at level passing this parameter here as if it was a method of inventory item. So that's the old school way. Let's look at the new way in C# 14 using extension members to do that plus more. So I'm keeping the old code here for comparison, but I've created a new class underneath where I'm going to have my extension members. The first similarity actually, and perhaps the only one, I still have to declare a static class. But then there is the new syntax here. You can see extension as a new keyword, and then I pass in the type name. From here on, it's just like using the source code for the type. You just declare everything inside the code block. So let's declare a static method on the type first. So this is a bit different than the extension method because this extension method here will be invoked as if it was part of the instantiated object, whereas this is an extension of the type. I have declared here what is pretty much a simple factory. I'm just creating a starter sword for new players, and I'm giving a name of Sword of Fate and then putting some values against the damage and the rarity and making this a static method on the type. So if you're going to create that item, I just called here var sort equals inventory item dot starter sort. But there's more, because look, now I can also overload operators. So remember that requirement I mentioned in the beginning where I want to combine items together? Well, I can do that now with extension members. I can have a static method that is an operator overload. So in this case, I'm overloading the plus operator and then passing in 2 inventory items, then just literally newing up a new one, keeping very simple. So combining the 2 names of those 2 inventory items, adding up their damage and then dividing by 2. With this, I can just literally do something like this. Create a fire gem. So this is a new inventory item. And then I just combine them, fire gem plus sword, done. So let's see how this looks like. And there you go. So this is the old extension method still. And now this is the new stuff. This is my factory method on my extension member declaration there, Sword of Fate. And this is the combination of those 2 items here that came from this code here that I just used extension members to overload my operator, and boom, off I went. How cool is that? But okay, this is still like static stuff. And in fact, this is static on the type itself, right? So we're not even getting that kind of sugar-coaty, nicey syntax of calling things on the instantiated object. So how do you do that? Well, I declare an extension block, but this time, instead of just doing extension inventory item, I actually have to give a variable name. Now, this could be anything, right? It's just a reference so you can use it inside that code block. I am declaring a separate block here, but you could have put everything under the same extension block. You do need to have the full syntax here. Otherwise, this won't work. Here, I'm gonna keep them separate. I declare the block where I'm gonna have my extension members. I'm just gonna have a simple property. It's just a text representation of how rare that item is, right? Common, uncommon, rare, epic, legendary, just a getter property. But now also what I want to do is improve the name of the items that get combined. Because before I had like fire, gem, sword of fate. So I wanna do better than that. I wanna end up with fire sword. I created a property here called public string combine name. Again, the important thing is no static, nothing, as you can see. You just declare the properties as if you're editing the source code of the type. And then I got getter, and then got my little algorithm here, and I'm calling that the combine name. And when I do my operator plus overloading here, I just change, instead of having the name and name, I have the combine name and the combine name. So I instantiated the starter sword again here, and then I just printing the sword name. But now I'm printing the rarity label. Now the name is still native to the type, right? Inventory item has not changed. It's right here. But the rarity label is from my extended properties here. Yet they look exactly the same when you call. They look like they're part of the type, which is the magic. And then combine my items like before. I have a fire gem, and then I combine the fire gem with the sword. But this time, because of the little update that I did with the combined name behind the scenes, hopefully the upgraded item name will come out a lot cooler. And then I'm also just printing the rarity label on the combined item as well. Let's run this. .net, not .tt. Whoosh. There you go. So we got Sword of Fate, and it's a common item, but then the upgraded item now is called Fire Sword, and the rarity is rare. And for my last trick, let's add an instance method to the type. Still within that extension inventory item block here, I add an extension instance method here called calculate damage. No static, nothing. We just declare the method as normal. And when I call it, it's gonna look like this. I'm gonna call the calculate damage on the upgraded item. What I want you to appreciate is that this now looks exactly the same as when we call the X here. See, it looks like a method on the type, except that this time we didn't have to do the static method with the this keyword before and all that. We just have very clean code declaration here. So let's see this in action. There you are. Easy. Please like and subscribe if you learned something new, and let me know in the comments, what do you think about extension members and any suggestions of topics that you may like me to cover in future videos. I'm open. Thank you very much for watching. See you on the next one.